All right, so we're going to talk about section 9.4, which is solving algebra word problems with strip diagrams. And what's most important here is that this is a way to kind of facilitate solving equations without having to use the variables. So it's a good introduction for students. And then you can add the variables with it. So we're going to show it with the strip diagram, but then also show it algebraically just so you can compare and see the difference. All right, so to begin with here, at a store, a hat costs 3 times as much as a t-shirt. And together the hat and t-shirt cost $3. How much does that t-shirt cost? So what you want to do is here, you want to go ahead and create two different parts, right? Because we have a hat and we have a t-shirt. So what we're going to do with that is we have our hat here. And it's kind of nice also if you want to use different colors. Students kind of like that where you use different colors. They like to use different colors. So we have a hat and we have a t-shirt, and the hat costs 3 times as much. So here is our t-shirt, and then up here will be our hat, and it's going to be 3 times what this is. So we have 1, and really, you know, it's your choice. I always connect them when we're talking about it's just different parts. So always connect those. And they should be equal parts. I know mine don't look spectacular, but they should be equal parts in there. All right, so the hat is 3 times as much as the t-shirt. Now together, okay, so together, those cost, this is an error. This should be cost $36. I'm not sure what happened there. So you see that's a $36. So together, those cost $36. So what I know is that I know that I have 4 equal parts here. All right, so if I have 4 equal parts and I know the total, then I can take that total, divide it by 4, and find what each part, the value of each part. So these are each going to be 9. So how much does the t-shirt cost? Well, if the t-shirt is 9, and just to double check that, 3 times this would be 27. 3 times 9 is 27. 27 plus 9 is 36. Just a good way to kind of go back and check that. Now, that's an easy way to do that without having to use any variables. Now, let's go ahead and input variables in for those. So here's our second way with variables. I'm just going to do this here. Bear with me. And here's our hat, here's our t-shirt. T-shirt is 1. All right, so, and again, we know it's 36. So if we want to go ahead and take each of these and just make them, they're unknowns. We'll just say we don't know what those cost, right? Because we don't. But we do know their total of 36 again. So if I just add up all of these unknowns, it's 1, 2, 3, 4 x's. So 4x is going to equal 36. And so to solve, now again, this is a little more upper level. They begin to solve one-step equations, I believe, in 6th grade, all right, and 7th grade. So here we divide by 4, and we find that x is equal to 9. So just a way to do that algebraically, and also just do it without any variables. So let's look at the next one. So if you want to pause and go ahead and try and do this number 2, and then come back and see how you did on it, go ahead and do that. So here there are 180 blankets at a shelter. The blankets are divided into 2 groups. There are 30 more blankets in the first group than in the second group. All right, so that means we're just going to have 2 groups. So let's say we have group 1. Let's put a 1 in there. Maybe I'll put it on the outside here because we might want to fill in a value. So 1 here, and then here is our second. Now we do know that there are 180 blankets total, but we also know that there's 30 more blankets in the first group. So we need to add on to here what we know, which is 30 more. But we know that the total blankets for both of them is 180. So here we want to be sure that we, because we have 2 equal parts, what we want to do is go ahead and just subtract this value from here. So we want to begin by taking 180 minus 30, and that's 150. So these 2 parts equal 150. So once I know that I have equal parts, then I can take that 150 and divide it by 2. and that's going to equal 75. So that means this is 75 and this is 75. So the question says, how many blankets are in the second group? So the answer is 75 blankets. And I really did emphasize that's important, and I wasn't very good up here because it says, how much does a t-shirt cost? We want to be sure and put $9 so that we are answering the question that it asks for with the units, okay? So now let's take a look at this the other way. Let's go ahead and do it algebraically. So algebraically, we have, again, these two parts. And this one has 30 more. And we know that they total 180. So what we do is we don't know, these are the unknowns. Those are the variables because we don't know what those are. So let's go ahead and add up everything we have here in our strip diagram. So we have 1x plus 1x is 2x. Plus we have this 30 added on. And all of that total should be 180. And then we're just left with a two-step equation here. So we want to eliminate this and make it 0. So we subtract 30. But remember, an equal sign means keep both sides balanced. Okay, so that's what an equal sign is. It means you're keeping both sides balanced. What I do on one side, I have to do on the other. So since I subtracted 30, I have to subtract 30 here as well. All right, and then again, we divide by that coefficient, and x is equal to 75 blankets. So set up algebraically, which is a higher level, granted, right? And then we have this being able to solve it without using any variables. And I think sometimes even thinking about even an 8th grader doing algebra, maybe, doing this first helps. Just kind of getting this visual of doing a strip diagram and putting it into parts and then bringing it over here. I don't know, but something to think about. All right, so on a farm, 1/7 of the sheep are gray, 2/7 of the sheep are black, and the rest of the sheep are white. There's 36 white sheep, so how many sheep in all are on the farm? So first of all, we know that we have this broken up into 7 parts. So let's break 7 parts. Okay, so we have 7 parts, and we know 1/7 is gray. So we know this 1/7 is gray. And then we know 2/7 are black, so we'll just put the color in here. So here's 1/7, here's 1/7. And then we know the rest are white. But we also know that's 1, 2, 3, 4 sevenths as well. But now it tells us actually that the white sheep has a total of 36. So that makes it kind of nice. I could find out what each one of these, by equal parts, we could figure out what each one of those are. So because there's 4 equal parts, if we take 36 divided by 4, that gives us 9. So 9, if I go through and I refigure this out, these are all 9 and they're all equal parts, right? So that means they all have to be 9. So I'm just going to kind of write it below it. So all of these are 9. And then the question states, how many total sheep are on the farm? Well, if each of these are 9, that's 7 of them. I can either do repeated addition, add them all together, depending on your grade level, or I can take 7 times 9, either way. So 7 times 9 is 63 total sheep. Okay, or I could just do 9 plus 9 plus 9, either way. Now, algebraically, it's a little bit trickier, I thought, with this one algebraically when I took a look at it. But when I'm going to redraw this. So again, in our 7 parts, what we know is that these 4 right here are 36. So if I just take these 4 parts right here, I know that those are the white sheep and that those are 36 because it tells us that in the problem. But I don't know, I have a 7th here, I have a 7th here, and I have a 7th here that I don't know what that is. So these, when I bring these together, these are kind of the unknown parts right here, but we do know that they're in 7ths. So what I can do is I can take 1, 2, 3 sevenths x, or I could say 1/7 x plus 1/7 x plus 1/7 x, okay? and that plus 36. And what we want to know is what is the total? That's our other unknown, is we don't know what the total is. We know parts of it, right? But we don't know, sorry about that. We know parts of it, but we don't know exactly what the total is. So this one's a little bit trickier as far as solving it, and it's dealing with fractions. So this is a little bit higher level, more of a challenge. So we're going to subtract 3/7 x from both sides. And then what we have to do over here, this becomes 0. Sorry, I keep going too low there, is that we need to figure out how to subtract these. So if we know that one whole is 7/7, can I go ahead and just get a common denominator there, which is 7/7, which students will be able to do at this grade level, okay, at like a 4th or 5th grade. And so 7 minus 3 gives us 4/7x. So we had to get a common denominator there. Now there's a couple of ways to solve this. If they're 6th graders, they know how to do this, but you're going to multiply times the reciprocal. Okay. What I'm going to do is I'm just going to get the 7 out of the denominator. I'm just going to take it in 2 steps, but you could do it either way. So 36 times 7 is 252. These would cancel and we're left with 4x. And then we divide by 4 and x is equal to 63. And that again is total sheet. Okay. And so again, if I just check that, like 1/7 of this total, 1/7 of 63 would be 9. And that's what we want it to be. So you could double check that. So this is algebraically, and again, this is without the variables. So I hope that makes sense to you. I think it's really important visually for students to be able to see these, okay? And hopefully you can come up with some neat ideas also using visuals, and strip diagrams are a really good way to do that. I know you learned those clear back in chapter 1, and we still are using them here in even our little higher levels. We're still using the strip diagram, so they're really, really helpful for students as far as a visual model. So, all right, you guys, I hope you have a fantastic day. All right, thanks for tuning in. See you later.